Alright, so the third problem from last weekly contest, fruits on into baskets part 3. We are given two integer arrays, fruits in baskets, each of length n, and where fruits of I represents the quantity of the ith type of fruit, and baskets of j represents the capacity of the jth basket. So from left to right, we want to place the fruits according to the following rule. Each fruit type must be placed in the leftmost available basket with a capacity greater than equal to the quantity of the fruit type. Each basket can hold only one fruit type, and if a fruit cannot be placed in any basket, it remains unplaced. We want to find the unplaced types of fruit after all possible locations are made. So if we take an example, something like if this is fruits of uh, fruits array, and then the baskets array is something like this. They are both are of same length, right? uh, we want to find the first basket that can handle a capacity of 3, that is 8, right? So initially they are unused, but we are going to use 8 because we have to process the ith index. Our answer is currently 0 because nothing is unplaced as of now. We try to place 4, we place it at this index. We place 9 at this index because that's the leftmost available one. We place 2 at this index. We place 10. We can't place 10, so we increment the answer. We place 4 at, I guess, this index. We place 6. We can't place 6, and we can't place 7. So what I'm essentially doing is I'm asking at ith index, right, for this value, suppose 2, for a value at ith index, I am asking the maximum that I have in the range 0 to 7, max value of baskets in the range 0 to 7. Now if I break this statement into two parts, right? I can break this statement by saying max value of baskets in the range 0 to 3, and so these can be different, right? Max value of baskets in the range 0 to 3 and max value of baskets in the range 4 to 7, these two can be different. And if both of them are valid, in the sense both of them have a maximum value that is greater than equal to the value at the ith index, in that case I'm going to choose the left one, right? Otherwise I'm going to choose the one that is valid, that's the right one. If both of them are invalid, I'm going to count this as the answer, it will contribute to my answer. So this is something that we need to do efficiently, and like this process already suggests, we need to use segment tree for efficient lookup of login time. The lookup will be what? Max value between two range, right? So if I try to form a segment tree using this baskets array, so what I can do is have a 0 to 7 segment tree This is going to be 0 to, I guess, 0, 1, 2, 3, 4, 5, 6, 7, I guess 0 to 4, 5 to 7. This is further divided 0 to 2, 2 to 3 to 4. This is 0 to 1, 2 to 2. This is 0 to 0, 1 to 1, 3 to 3, 4 to 4, 5 to 6, 7 to 7. This is 5 to 5, 6 to 6. So at the 0th index, I have a 2 as the maximum, 1th index 8 as the maximum. This will lead to 8 as the maximum in the range 0 to 2. 3 to 3, I have a maximum of 3. 4 to 4, I have a maximum of 6. Combined maximum of 6. Combined maximum of 8. 5 to 7, actually 5 to 5, I have a maximum of 1. I guess 6 to 6, I have a maximum of what? 7 and 11. This is combined maximum 7, 11, and lastly 11. So maximum of the other two, that will be 11. So, and the same goes for all the other child. So what we are essentially doing is we are processing every fruit. So 3 is going to be processed. I'm going to come here in this segment tree, check. I'm able to place it at some index. I don't know what, because the maximum is greater than equal to 3 that we are at. But since both of them are valid, I'm going to go for the left one. I see 8 still valid, both of them. I'll go left. I see 8 still valid, both of them. I'll go left. I see 2 and 8, so the right one is what we are going to choose. But the segment tree must know that we have chosen this basket. So what we can do is choose this, make this 0, and keep updating the values. So this becomes 2, this becomes 6, this becomes, this stays 11, right? So let me clear this a bit. This becomes, this changes and this changes. So this becomes 0, this becomes a 2, this becomes a 6. We come at 4th index. I'm sorry if this is confusing. Let me, make things a little bit better. Let's copy this, go to the notes section, take this here, copy this, and continue. So I am at this 4th position. I'm at 4th position. Let me, now answer is 0. I see that this is the first index, and I'm sorry, this is the fruit. So the capacity is possible. I can go left. I see 6, that is possible. I try to go left, but I can't. So I go right. I see 6, valid. I see left is not valid. I go right. I change this 6 to 0. This becomes 3. This becomes 3. Right? So this becomes 3, 3, 0. This was valid, so let's move forward. Let's process 9. This time 3 is not possible, so I go left or I go right, and I eventually change this one to what? This becomes 0, this becomes 7 and a 7. I go here, I see 2. I am able to do it on the left side, so I'll prefer left. I'll prefer left. I'll prefer left. Update this to 0. Update this to I guess 0. 2 2 was what? 2 2 was 1. Was it 1? Yeah, I guess this was 1. I'm sorry. So this becomes 0. This becomes a 0. This becomes a 1. This becomes a 3. And this stays a 7. Right? So we get the idea. Right? So we move to 10. We can't update it. We add it to our answer. We move to 4. We can't, we can update it. We can't update it on the left side. So we go right. We update this 7. And we update this 7. We update this 7. We make this 0. We make this 1. We make this 1. And finally we make this a 3. We go forward. We have a 6 and a 7. We see that the maximum is 3, so both are not possible. We add both of them to our answer, making it 3. And that's it. That's how we are going to solve this problem. So creation of segment tree is going to take a lot of the thinking, right, and the coding. So let's create a segment tree. We all have our own ways of creating it, so I will create it in my way. So a left index, a right index is what we need. We want to store a value that's going to represent our max value in this left to right index range. Segment tree, that's going to be a pointer to the left tree and the right tree. A constructor, right, that's going to be the left index. It's going to take the left index and the right index whenever we create a new node or a new tree, and it's going to have a value. Initially, we can have a default value of 0 instead of creating a separate constructor. Left tree and the right tree will be null, and the value will be value. The left index will be the left index, and the right index will be the right index. The next thing is we are going to create a add node function, which is going to build our the whole thing. So let me, instead of having a add node, let's have build function. It's going to take a left index, the right index, and the vector. If the left index is equal to the right index, that means we are at the leaf position, right? So we are going to have value as the as the array value at the left index or the right index, anything is, you know, possible since both are same, and then we can return. Otherwise we are going to find the middle index using the left and the right index and divide it by 2. So now we are going to create the left tree and the right tree. So it's going to be a pointer of left, creating the left segment tree. Here for the left index and the middle index, we are going to not pass the value because we are going to use the default value. Here for this right tree, it will be mid index plus 1 to right index. Alright, the next thing is the pointer needs to be updated of the current tree to the the left tree to the left pointer, the left pointer to the left tree, and the right pointer to the right tree. And then we are going to call the build function on the left tree and the right tree with the respective indexes. For the right tree. Alright, now the value of the current tree needs to be updated. That should be the maximum among the left and the right value. That's it, we can return. That's the build function. Now comes the update function. So here we need to prefer left when both valid. If only right valid, then take right. Otherwise we can return false. Right, in the other cases when we are valid, then we can return we can update the preferred one and return true for both of them, right? So this is going to just take a fruit, right? If we have the current tree value is great less than fruit, then it's not valid. So we can it's valid, right? Sorry, this of value is less than fruit, so it's not valid. I'm sorry, return false in that case. Now whenever it will be valid, we must be at some point where the left and the right index are same, right? That's where we can update the value and return true. So what we can do is have that check left index of the current tree, if it's equal to the right index, in that case update the value to 0 and return true. So now I can recursively call the left trees function left trees update function with the fruit. This is going to return me boolean. If it's returning a true, in that case I can update its value to what? To the maximum of its two children, right? To the maximum of its two children value, that is left tree value and the right tree value, and we can return true. Alright, the same thing goes for this one. I think the better way or the better thing to do is actually do the same thing for the other one as well, because for this one as well we are going to do the same thing, right? So what we can do is do it together. Whichever will be true, it will always return true, otherwise it will return false, right? So now comes the easy part of firstly getting the n, creating a segment tree with this 0 comma n minus 1 of this range. For this range I am going to call the build function. This build function is going to take the left index, the right index and the array, that is the fruits or the baskets array. We are going to have answer which is going to count the unplaced fruit types, and next thing is we are going to iterate every fruit. So let's, instead of enumerating, let's get the fruit from fruits, and for each of them let's call the tree update function passing the fruit, and if it is returning, it's returning a boolean, right? If it's not true, that means we have not updated it, that means we have not found the capacity to do it, and we can return the answer. Let's see if this works. This should be a fruit. I'm sorry, fruit. Now there should be a semicolon. Alright, this works. Let's submit and see. So the building is going to take what? This is going to take a time complexity of uh, adding every node in the segment tree. So it's going to take n log n just building it. So this is n log n, and for each of the fruit we are doing a lookup, so that's also going to be n log n, and that's the time complexity. Space complexity will be uh, the space of the segment tree, and we are not doing anything else, so that's it. So that's the third problem of the contest. Thank you.